Hello again, my fellow friends. This is your NOLA Mathman coming again to do another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound. I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
So let's get into section 3.5. We're looking at operations with matrices. After watching this video, students will be able to solve matrices, various operations involved with matrices. The concept we're looking at is linear systems, and the skill we're looking at is solving matrices using operations. And when we say operations, we mean adding, subtracting, multiplying, dividing, the four major operations. So with no further ado, let's get into the video. So we're starting by performing operations with various matrices. They give us the first group of problems where it says perform the indicated operations if the matrix does not exist. Write impossible. So I'm putting up here, the NOLA Mathman is putting a rule that you want to always follow when you're adding and subtracting matrices. It says to add or subtract matrices, the actual matrices you're dealing with, must have the same dimensions. So what do you mean by dimensions? Dimensions mean M by N. M represents rows, N represents columns. So as you can see, this is the general form of a matrix. If you want to write the actual dimensions, and this is M represents, again, the rows, N represents the column. In order for you to add or subtract them, the M and N have to be the same for both matrices. And so that's the first thing we want to check when we do a particular problem involving addition or subtraction. So that's a very important rule. And so now that we know this rule, we can get started with our problems. So let's try, let's see here. Which one, I'm gonna make it bigger so you can see it. It was a little too small for my liking there. So we're gonna expand it a little bit. And so let's see, which problem do we wanna do? Start with number 1. So in this matrix, we have 5, -4. That's the values of the matrix, plus 4, 5. So we would call this type of matrix, the dimensions would be 1 row, 2 columns. We call it a 1 by 2. And so we want to write that first of all to make sure they're equal. Once they're equal, then we know we can add or subtract them. So we can add, since they have the same dimensions. As you can see, we circle a 1 by 2 problem. So how do you add them once you have the dimensions? Well, you add what we call their entries, their elements. So you take the first row, first column value, which is 5, and you can add it to the first row, first column of the second matrix, which is 4. And then you do the same with the second. You take -4 and you add 5. So that will give us a matrix that's a 1 by 2. And so your final answer will be 9, 1. And so the matrix will be dimensions 9, 1. Well, not dimensions, the values will be 9, 1 in that particular matrix. So number 1 is done. Now we move on to probably number 2, because that's a subtraction one. We did addition one, so we probably should do subtraction. So we'll see what the NOLA Mathman does. Yeah, it goes to number 2. So in this one, we have what we call a 2 by 2 matrix, 2 rows, 2 columns, meaning 2 across, 2 vertical, 2 horizontal, 2 vertical. That's one way you can look at it. So The first thing we do before we decide to subtract the corresponding entries, we want to determine the dimensions of the two matrices. Now, the first one is 2 by 2, the second one is 2 by 2. And again, they're equal, which means we can subtract the corresponding entries to get a new matrix. And that's what we're going to do. So we can subtract. So we want to write that down and lets us know we can do it. So at this point, we will subtract the corresponding entries. 8 minus 0 will be 1 entry in the first row, first column. Next one will be 3 minus negative 7. The next one will be negative 1 minus 6. And the last one will be negative 1 minus 2, which will pop up here in a second. So using your order, your basic math rules of subtraction, you simplify. 8 minus 0, 0. 3 minus negative 7 will change into 3 plus 7, which will give us an answer of 10. Negative 1 and negative 6 is basically negative 7 because you're adding like signs. And negative 1 and negative 2 is negative 3. And so your final matrix will have those entries. 8, 10 in the first row, in the second row, negative 7 and negative 3. So we're done with that one. We erase our work for number 2. And let's see what we do next. Oh, we're going to do number 3. So in this problem, we have 3 1 and 6 horizontal entries, and then we have vertical entries of 4, negative 1, and 2. Now again, the first thing we do before we do any addition or subtraction, let's write the dimensions. Dimensions of the first matrix is 1 by 3. The second matrix is 3 by 1. They're not equal, so this basically means we cannot add them. And so the answer will be impossible. They cannot be added. I don't know if the NOLA MATHMAN will put impossible, but we know that they cannot be added. And so basically, you can say you have no solution. Directions said to put impossible, but the NOLA MATHMAN does not put that, but we know that that means the matrices are impossible to solve. So you would put impossible, the NOLA MATHMAN. I guess that's not great academic language to him, so he didn't use it. I don't know. Okay, let's do another one that involves, looks like some multiplication involved. Yeah, let's try one of those type. See what we're gonna do. Let's see what the NOLA MATHMAN does next. So we'll go to number 5, which has a little multiplication. We have a term written outside of matrix 3 times the quantity of 9, 4, and negative 3 horizontally. Now, this is called a scalar. And scalar means outside is a scalar, and you just multiply all the terms in the matrix by the term. It's almost like the distributive property for the matrices. So we will multiply the first entry by 3, 3 times 9. Second one's 3 times 4. Third one's 3 times negative 3. And when you solve that, you will have your final answer, which is 27, 12, and negative 9. Which, what are the dimensions of that? Yes, 1 by 3, 1 row, 3 columns. I was just checking, see if you remember do little dimensions. Okay, so let's try another one, number 6. We have matrix 6, negative 3, minus 4 times the horizontal matrix of 4 and 7. So again, what do we do first? Well, we have to simplify that second matrix. We have to take the negative 4 and distribute it into the other one. So we put 6 minus 3, we do nothing to the first matrix. want to simplify the second matrix by multiplying 4 times 4 and 4 times 7, should be our second entry into this matrix. And then we're going to simplify that so we can get a new matrix that is a 1 by 2. So we keep the first matrix the same, 6, negative 3. We multiply 4 times 4 and 4 times 7, and we get 16 and 28. Now we check the dimensions. They're both 1 by 2, which lets us know we can simplify these matrices by subtracting the corresponding entries. 3 minus 28. That will pop up here in a second. And so there we go. Took the NOLA Mathman a minute to figure that out, but I don't know, maybe took a little bathroom break. So 6 minus 16 is negative 10. Negative 3 minus 28 is negative 31. And so your answer will be negative 10, negative 31, a 1 by 2 matrix with those entries. So now we're going to erase and see what we do next. Let's so we see which problem we're going to get to next here. So I hope we're learning. We're doing a variety of different operations with matrices. We've done addition, subtraction. We've done some multiplication. And so we want to do a variety of different problems so that you can gain confidence in all the concepts. So now we're going to do number 7. We have negative 2 times a matrix with the quantities of negative 2, 5 and 5, 9. And we're going to add that to a matrix of 1, 1, 1, and 1. Should be addition. Looks like the NOLA Mathman made a mistake. He put subtraction instead of addition. Let's see if he corrects it. Now we'll just subtract it. It'll be another good example to do. So the first step is we distribute that negative 2, that's the scalar, into all 4 quantities of the first matrix. And we will get negative 2 times negative 2, negative 2 times 5, negative 2 times 5, and negative 2 times 9. So we'll do that, we multiply each of those, and we end up with 4, negative 10, negative 10, and negative 18. The second matrix does not change. We want to check the dimensions. They're both 2 by 2. So in this case, you were supposed to add, but we're just going to subtract. Looks like the NOLA Mathman just made a mistake there, because the problem says addition and he subtracts. Maybe he wanted to make it a little more challenging for himself. I don't know. So we're just going to subtract. It doesn't change anything because it shows us how to do operations with matrices. So what we're going to do now is we're going to subtract the corresponding quantities like we've been doing. So we will have 4 minus 1, since those 2 entries correspond. Negative 10 minus 1. First row, second column. We got negative 10 minus 1. And we have negative 18 minus 1. And when we simplify those, we end up with 3, negative 11 across, and then the bottom row will be negative 11 and negative 19, and so we get that answer. It should have been addition, so again, I'm going to have to get with the NOLA Mathman and tell him to be precise in writing down the work. That's very important. And that's a good lesson to you, students. Be always very careful in writing your problem. It's a common mistake even the experts like the NOLA Mathman can make. Anybody can do it, so it's always good to check over your work. Let's see if the NOLA Mathman writes it correct this time. He normally never does that, so he must have, I don't know. He might have had a little kryptonite episode, I don't know. Let's wait. So we're gonna do number 10. So we have 3 times, and we have a, what dimension would you call it? You're right, it's a 2 by 3. And the first row is 3, 1, 3. The next row is negative 4, 7, 5. And so now we have minus 2 times another 2 by 3 problem, which is 1, negative 1, 5, and 6, 6, negative 3. We should pop up here in a sec. There we go. So again, the first thing we have to do is use our little multiplication to distribute the 2 scalar terms into the matrix. So in our first one, we will have 3 times each of the entries. 3 times 3, 3 times 1, 3 times 3 in the first row. Second row will be 3 times negative 4, 3 times 7, and 3 times 5. And then we're going to subtract, and we're going to distribute the 2 into the quantities. We're going to rewrite that. We don't have enough room, so we're going to use right up below. 2 times 1, 2 times negative 1, 2 times 5, and we will have 2 times 6, 2 times 6, and 2 times negative 3. And that will be our new matrix. And so now we'll simplify each of the 2 matrices, and then we'll subtract the quantities after that. So in our first matrix, 3 times 3 will give us 9. So we'll have a row of 9, 3, and 9. Our second row of this new matrix will be negative 12, 21, and 15. So we will now simplify the second matrix, 2 times 1. You'll have a first row of 2, negative 2, and 10. And our second row will be 12, 12, and negative 6. So now, like we normally do, we have to check the dimensions and make sure they're the same. The first matrix is 2 by 3. The second is 2 by 3, so they're equal, which allows us to subtract the corresponding entries, which we will do to get our answer. So, looks like we don't have enough room, so we're going to have to erase some work here so that we can have enough room to do our work. So that's what the NOLA Mathman does right now. He wants to create some space so that he can do the work. So that's what we're going to do here. I got a little space in the bottom, so okay. So we're going to subtract each of the entries. First entry, 9 minus 2, 3 minus negative 2, and 9 minus 10. That's in the first row. Second row, the calculations of negative 12 minus 12, 21 minus 12, and 15 minus negative 6. So once we simplify all these quantities, we will have our final matrix. 9 minus 2 will be 7. 3 minus negative 2, that's 3 plus 2, which is 5. 9 minus 10 is negative 1. Negative 12 and negative 12 is negative 24. 21 minus 12 is 9. And again, you will change the negative of the negative to plus, and that will give us 21. So our final answer is the first row, 7, 5, negative 1. Bottom row, negative 24, 9, and 21. So we're going to move those out the way, and we're going to try another problem here, another type of problems involving operation that gives us 3 matrices, A, B, and C. And it says use A, B, and C to find the following. And so that's what we're going to do. Let's see what we're going to do. Which problem will we do with this? So, this is a different type of problem. So again, it's a little different. They will now give us some problems involving A, B, and C, and we're going to simplify using the matrices that are given. So we're going to start with number 11, which is A plus B. So we write the A matrix, which is 3, 2, 4, 3. You write the B matrix, which is 2, 2, and 1, negative 2. And we're going to add them. So in order to add them, we have to check the dimensions. First matrix, the A1 is 2 by 2, the B1 is 2 by 2, so we know they're equal. And now we're going to add their corresponding entries to get our final answer for A plus B. And that's what we're going to do, which we've been doing. So this should be familiar with us. And so we will add the entries. First entry in the first row is 3 plus 2. The second one is 2 plus 2. In the second row, we have 4 plus 1. And we have 3 plus negative 2. So when we simplify that, that will be our final answer. And therefore, we will have a matrix of 5, 4 in the first row. And the second row will be 5 and 1. And so that is our final answer. And do number 12, B minus C. So we write the B matrix 2, 2, 1, negative 2. We subtract. We write the matrix for C, which is negative 3, 4. First row, 3, 1, second row. And again, we gotta check the dimensions. Dimensions are 2 by 2 for the B and 2 by 2 for C. So since they're equal, we can now subtract the corresponding entries, which we write here. And so that's what we will do. So in our first row, our calculations will be 2 minus negative 3. Our second row, our next second entry in the first row will be 2 minus 4. And in our second row, our calculations will be 1 minus 3 and negative 2 minus 1. And once we simplify that, we'll have our final answer for B minus C. Negative 1 and negative 3 is positive 3. 2 plus 3 is 5. 2 minus 4 is negative 2. 1 minus 3 is negative 2. Negative 2 minus 1 is negative 3. So our final matrix is 5, negative 2 in the first row, negative 2, negative 3 in the second row. So we're done with that one. So again, the more of these you do, the more confidence you get. As you can see, we do the same concepts over and over. We want to check the dimensions before we figure out if we're going to add or subtract. And those processes never change, no matter what type of matrices you deal with. So now we're going to get to our next problem here. We're going to do number 14. And so we have A plus B plus C. So we write those matrices. The first one, A, is written there. Then we write B next, which you can see above, 2, 2, 1, negative 2. And then we will add the third matrix, which is C. And we write that there. So again, we have to check in order to add all three. It's the same rules as 2. You need to make sure the dimensions are the same. All three dimensions are 2 by 2, so that works. So now we're able to add all three entries. So instead of adding 2, we can add 3 of the corresponding entries in one big matrix. Because addition is commutative, it doesn't change anything to add 3 as opposed to 2. So that's what we're going to do. So in our first entry, first row, first column, we will have 3 plus 2 plus negative 3. That should pop up any second here. 3. That's the first matrix. 2 from the second matrix. Negative 3 from the third. And we're going to do that with each of the corresponding entries. So in the next row, you have 2 plus 2 plus 4. And then in the second row, your first calculation will be 4 plus 1 plus 3. And then the last calculation will be 3 plus negative 2 plus 1. So once we add all those together, we will have our final answer. So again, we can go from left to right. 3 plus 2 minus 3 is 2. 2 plus 2 is 4, plus 4 is 8. 4 plus 1 is 5, plus 3 is 8. And 3 plus 1 is 4, minus 2 is 2. And so that will be our final matrix right there. First column, or first row is 2, 8. Second row is 8, 2. So again, we have used the principles of matrices to simplify 3 terms being added. As you can see, it's no different than adding 2 terms. So that's what I wanted us to see there. So we get rid of that problem. And we go to our next group, 15 through 18. We'll expand it a bit so people can see there. There we go. And now we're going to pick another problem to do. Which one do you think we're going to do? Oh no. Which one do you think the NOLA Mathman is going to do? Well, probably. Oh, let's do 16. We have a negative number being multiplied by a matrix. Something a little different, looks like. You know, we did a problem like that earlier. So we put -5. That's sort of like our scalar term. We will multiply all our entries by -5. And so when we rewrite it, we will have -5 times -3, -5 times 4. And the first row, second row, -5 times 3, -5 times 1. And once we multiply those, we will get our final matrix, which will be -5 times -3, positive 15, like signs. -5 times 4 is -20, unlike signs. -5 times 3 is -15, unlike signs. -5 times 1 is -5, unlike signs. And so that's our final matrix. Alrighty, gives us a chance to review some of our basic math rules a little bit, which is good. And which one will we do next? My nose is itching a little bit, that's weird. Let's try number 17. We have A minus 4C. So we write the A matrix, 3, 2, 4, 3. We put minus, we'll write 4 times the C, which is -3, 4, and 3, 1. So again, before we subtract the 2 matrices, we have to distribute the 4 into the second matrix. That's what we're going to do first. And you will see that in the step coming up. Yeah, 4 times -3, we distribute 4 times 4. And in the second row, it'll be 4 times 3 and 4 times 1, which you will see in a sec. So once we do that, we will simplify those and get our answers. We keep the first matrix the same. Second matrix, 4 times -3 is -12. 4 times 4 is 16. 4 times 3 is 12. 4 times 1 is 4. So now we have to check the dimensions to make sure they're equal so that we can subtract. They're both 2 by 2, so now we can subtract the corresponding entries to get our final answer. So again, we need room there, so the NOLA Mathman is going to erase our entries so we can have some room to do our calculations here. We'll erase that there. And leave our last step up so we can see what we will do here. We got to remember to put our subtraction sign between the 2 terms, which I think we're going to do here in a sec. There you go. There goes the subtraction. And we proven that they are the same dimension, so now we're just going to subtract the corresponding quantities. Once we erase here that work, that's what the NOLA Mathman is going to do. So in our first row, our calculation should be what? What do you think they're going to be? Let's try 3 minus -12. And what's the second calculation in that first row going to be? Yeah, you're right, 2 minus 16. Then in our second row, we will have 4 minus 12, and we will have 3 minus 4. And so now we want to simplify and get our answer. 3 minus negative 12 is going to be 3 plus 12, which is 15. 2 minus 16 is negative 14. 4 minus 12 is negative 8. And 3 minus 1 is negative 1. And so that's our final answer. Excellent job. So again, very good job. As you can see, we've done a variety. So again, the more you do these, the more different types of matrix operation problems you see, the easier it will become for you to do. And so that's what we want to do here. So, we will now do number 18. We have 2b. We write the B matrix here, substitute that matrix for B. Then we will put plus, we will write 3. We'll substitute the matrix for A. And now, like we've been doing, we're going to distribute the 2 and 3 into their corresponding matrices and multiply. And so we will get the entries of 2 times 2 and 2 times 2. We will get 2 times 1, 2 times negative 2. In our first matrix, we distribute 3 into the second. We will have 3 times 3, 3 times 2, 3 times 4, and 3 times 3. Once we do that, we will simplify the matrices. The first matrix will be 4, 4, and 2, negative 4. And we will add that to the new matrix, which will be 9, 6, and 12, 9. So again, in order to add the matrices, we must make sure that the dimensions are the same. And they are. They're both going to be 2 by 2, which lets us know we can add the matrices together. So again, our final step will be to add the corresponding entries together and to get our final matrix as we've been doing. And so we want to show all that work. So we need to erase some work so we can have enough room to write down our work. Again, we erase the work we've done. And we're going to rewrite our last step here. And quickly here, we have matrix 4, 4, 2, negative 4, plus the matrix 9, 6, 12, 9. And again, since we know the dimensions are the same, we can add the corresponding quantities to get our answer. And so in our first row, our calculations will be 4 plus 9 and 4 plus 6, which should appear any second now. And the second row, the calculations will be 2 plus 12 and negative 4 plus 9. So we add those together, and our final matrix will be first row 13, 10. The second row will be 14 and 5. That's our final answer. And so let's see where we are now. I think we've done a lot of different examples at this point, so we should be very comfortable and confident with our process. And so basically, at this point, we have finished another math adventure. At the end of this video, you should be able, and we're now done, so you should be able to solve matrices with the various operations of addition, subtraction, and multiplication. And so until we have our next math adventure, the NOLA Math Man is signing off. Have a blessed day until we meet again.